So we're at the Freescale Technology Forum here, and you're from ARM. And what is it that you do at ARM?
So I manage the university relations, the relationships between academia and industry. We look after curriculum, we look after branding. To some degree we look after human resources, so we also interface with the various departments that are looking for internships, summer research positions, things like that.
So, I mean, how many, like there's a lot of students working on ARM technology all over the world, and they need tools, they need books, or what do they need? Resources on the internet?
Exactly. So they'll look to ARM for software tools, hardware platforms. We also make some recommendations on textbooks. There are a number of new textbooks coming out, specifically around the Cortex M3 and M4. We also have an assembly language textbook. We have one that's specifically oriented towards the higher platforms like the Cortex A8 and Cortex A9. And we also help them address the needs of the students doing capstone projects, senior level projects, that sort of thing.
So what do the students like to do? They like to see robots moving, or what do they like to do to get involved and really interested in this technology?
Everybody does something slightly different. So we have some students working on very detailed VLSI designs that are actually being fabbed. So there are students that are building devices based around ARM technology that will go to, they'll go through MOSIS as an academic wafer run. We also have students that build individual projects around discrete components from our many partners, including Freescale, TI, NXP. And then there's a number of students that they'll work on a senior level project that has been already, the design has already been specified by the departments. So as an example, Purdue University has a senior level course that has been more or less laid out, and the student's job is to implement that particular design. One of them involved sorting a number of blocks made of different materials, and so those types of projects are hands-on. They're very goal-oriented, and students really find those interesting.
So does ARM work with all the companies to try to make these dev kits or these robots or these, like to make it easier for students to, or teams of students all over the world? What's ARM involvement in doing these designs? Right,
we don't actually get that involved with the end designs of the boards. We do find a number of our partners will build boards like the IMX starter kit from Freescale. Those are designed around cores that are being sold individually by our partners. So we don't get too involved in the applications of the parts or the development boards that are made to showcase those parts. But we find that once the partners have made those types of boards, they're very useful in universities.
So you were talking about standardizing because the student has to study for 4 years or a longer time, and technology advances so fast. So how do you kind of manage that?
We try to, so being in industry, we try to encourage the universities to really go for a standardized platform, something that is actually used in industry, so that when students graduate, they know that they can get a job with a Qualcomm or a Tektronix, something like that. We don't have a lot of say-so as far as what the universities actually choose, but we do try to get them to think about the idea of adopting, lights going out, we try to get them to think about the idea of adopting a standard platform that can be used for 4 years or even continued into the graduate program, so that the students don't have to constantly retrain themselves.
So do you think that the schools or at the universities are evolving very fast because the ARM industry is moving so fast?
That is part of the difficulty. You have a 4-year curriculum that gets more and more compressed, and the departments want to add in more and more information, and that makes it very difficult for an undergraduate EE student who now has to learn what would be considered the traditional EE curriculum in addition to learning the latest technology, which is very difficult. So by eliminating some of that ramp-up time, we hope that the universities will start to think about using that extra time that they would have, rather than retraining the students, they could actually get that much material into a 4-year program. It's very difficult, and I actually, we sympathize with students just entering the programs now because there is so much to learn.
So last year, I think the number was 6 billion ARM processors shipped, something like that.
Yeah, 6
so if you
billion.
learn to work on one of them, you can kind of work on all of these different ARM processors? Not really.
No, we hope so. So of the two families, you have the M family, including the Cortex M3, the M0, the M1, as well as the A family, so the Cortex A8, A9, and A15. Those two families are used so heavily commercially that the idea is if you train somebody to use even an ARM7, very old processor, but it's still quite heavily used in academia. If you trained on an ARM7, then moving to an A8 or an A9 is not as difficult as if you were to start from scratch or on an older architecture.
And are students having fun with ARM?
Absolutely. we think they are. Joe can probably attest to the number of students that are actually now using ARM in labs, using our software, using the hardware from many of our vendors, and using our vendor software as well. But yes, we do see an interest, and we see this momentum only growing every year.
So how many students? Can you say approximately?
We don't actually have a hard number. I don't think anybody has a hard number. It's very difficult to pin down. It's like saying, you know that people are reading a particular book. You know that they're buying that particular book, but you don't know exactly how many are actually using it. We are in hundreds of universities in North and South America. We're in dozens of universities in Europe. And so it's very difficult to tell with 50 to 100 students each term going through. Order of magnitude, we know that there's thousands of students.
And ARM employs, hires, I mean, like top people, but that's in a different kind of area. You're not going to like give jobs to the top students to win the robot challenge somewhere. Do you sometimes? Not really. That's a different.
So ARM, we're actually a much smaller company than people think we are. So worldwide, we're a little over 2,000 people now. But we cast an enormous shadow in the marketplace because of the number of partners, well over 130 now, that have ARM licenses that are producing ARM silicon. So ARM as a company, we tend to hire fairly leanly, but we're always encouraged to see a PhD student who happens to have a very specific skill. We're always encouraged to see good master's candidates coming out. So we do hire from those universities that we teach, but our partners also hire from those universities.
And I saw that some of the ARM employees have hobbies where they build crazy robots that do solve all kinds of things.
They solve Rubik's Cubes. Yeah. They make fish talk.
So do they go to universities to show what they've done and like in the hobby kind of thing?
No, not so
really?
much. Mostly those get displayed at the commercial conferences,
okay.
The Embedded Systems Conference West, TechCon, those sorts of conferences.
Right. Thanks.